Hi everyone, my name is Mike Lombardi. I teamed up with SubSalve USA at the start of the Covid-19 pandemic to produce the SubSalve Oxygen Treatment Hood. Our hood received emergency use authorization by the US FDA in August. I've offered several tens or more webinars on how to use the device, and what I've encountered is that the technique or approach to helmet non-invasive ventilation is often made too complex. I wanted to take the time to present a very simple methodology which is going to prove hugely beneficial, particularly when managing respiratory distress among large patient populations or when required to treat patients outside of conventional well-equipped hospital settings. Let's cover some basics. The SubSalve Oxygen Treatment Hood is very simply a patient interface for non-invasive ventilation. NIV via hood or helmet affords three principal benefits. First, it maintains positive airway pressure for the patient. Second, it allows you to deliver elevated oxygen fractions. Third, it allows us to mitigate aerosolized virus exposure to healthcare workers. The latter is particularly beneficial during the COVID-19 pandemic and a significant advantage over more conventional NIV interfaces such as masks, since patient exhalations are filtered. Recent research in Europe has provided us with some scientific facts. The administration of a continuous positive airway pressure through a helmet improves oxygenation and avoids intubation. A European consensus document suggests that helmet CPAP should be the first therapeutic choice for hypoxemic acute respiratory failure caused by COVID-19 pneumonia, mainly for minimizing aerosol generation. All hoods or helmets are intended to be used with high flow sources, typically greater than 60 liters per minute, to mitigate carbon dioxide rebreathing. The flow source does not determine treatment efficacy. This is a technical or configuration consideration based on the available resources. Helmets or hoods can be supplied by constant flow using wall gases, high flow blenders, Venturi devices, or with bi-level flow using BiPAP units or ventilators. These high flow resources may not be in abundance, so we should consider preserving these for the normal intended uses. As COVID cases continue to rise, we should consider using CPAP devices, which are abundant in an inexpensive high flow source. Large numbers of COVID-19 patients can be placed on helmet or hooded NIV using CPAP in a dedicated ward and treated proactively as a first response measure. There's no reason to wait for the patient to deteriorate before implementing NIV. This significantly decreases viral exposure to healthcare workers with the added benefit of increased airway pressure and elevated oxygen delivery. Both are beneficial even for mild respiratory distress. We've engineered a complete hooded positive airway pressure kit. This includes everything needed to ventilate one patient, both hardware and consumables. Additional sets of consumables, when procured following World Health Organization guidance, bring per patient equipment cost to $200 or less, including the flow device. This is very simple. It allows easy instruction for community healthcare settings in rural or resource-limited areas, field hospitals, or makeshift COVID wards. Our kit concept allows us to keep helmet ventilation extremely simple. Flow enters the hood via a CPAP device, flows out of the hood through a viral filter to both filter out any aerosolized virus, as well as provide the resistance needed to create pressure in the hood, and then we can additionally titrate in oxygen through a simple fitting placed at the CPAP unit. Both the operating system and the patient should be continuously monitored at all times. First, we want to ensure that flow through the hood is greater than 60 liters per minute to mitigate risks of carbon dioxide rebreathing. We can do this with a digital peak flow meter to gauge the flow passing through the viral filter on the expiratory path. Second, we want to have a thorough understanding of the range of pressure settings and the pressure drop from the breathing circuit. This will vary slightly from model to model of CPAP device. Lastly, we want to monitor the patient's vital signs as well as their oxygen saturation. This can be done with a pulse oximeter. I want to emphasize a warning. Not all CPAP makes and models respond to back pressure in the same manner. It's very important to follow device-specific instructions provided with the kit or the manufacturer's guidelines. To wind this presentation down, I want to take just a few short seconds to show how easy it is to don the hood, establish flow, and essentially be ventilating a patient. In close, I want to acknowledge several groups that have come together to help bring this information forward. SubSouth USA, VentilatorProject.org, HelmetBasedVentilation.com, the Health Bank, Mater Nova, Los Medicos Bolivianos Online, Commerce Rhode Island STEP Program, and Ocean Opportunity Inc. For more information, please visit www.oxygentreatmenthoods.com.